Today we are going to learn spherical reflecting surfaces first. Spherical reflecting surfaces. Spherical refracting surfaces की है. Spherical refracting surfaces are part of a sphere separating two transparent medium. Like for example, if I draw, a sphere, right? This is a sphere, and I open a part of that sphere. So this is a spherical refracting surface. This is a spherical refracting surface. Now see, this is the rarer medium and this is the denser medium. This is rarer medium, this is rarer medium, and this is denser medium. This is denser medium. So what is this? There are two types mainly: convex and concave spherical refracting surface. Concave and convex spherical refracting surface. Now, this is concave refracting surface. It is concave towards the rarer medium. See, this is the rarer medium, and it is concave, means it is inside. This is the concave part, right? It is not bulgy. It is slightly, part is pinched out. So whenever this is towards the rarer medium, then it is known as concave refracting surface. Concave refracting surface. Right. Concave refracting surface. Now, if it was like this, and this is the rarer medium. Now, here is the rarer medium. Here is the rarer medium, and this is the denser medium. And this is the denser medium. This is the denser medium. So towards the rarer medium, the bulgy part is present, right? So towards the rarer medium, the bulgy part is present. So this is a convex mirror. This is a convex, sorry, not a mirror, convex refracting surface, spherical refracting surface, or better known as lens, We will go into lens later on. First, we will see what happens in a refracting surface. Now, in a refracting surface, there are two parts, concave and convex. Now, there are some points which you need to remember. What is the pole, right? So, if I take this refracting surface, then if I draw a straight line passing through the center of the mirror, right? So, this point is known as O. This point is known as pole. This point is known as pole. And second is the center of curvature. Now, this mirror, this spherical surface was a part of this sphere, right? It was a part of this sphere. So, center of that sphere was somewhere around here. This is the center of the sphere. Then this point is known as center of curvature. This point is known as center of curvature. This point is known as center of curvature. Center of curvature. And the distance between the pole and the center of curvature is known as this distance It is known as radius of curvature. This distance is known as a radius of curvature. This distance is known as radius of curvature. And the principal axis, this line joining the center of curvature and the pole is known as the principal axis. The line joining the center of curvature and the pole is known as principal axis. And aperture. Aperture is the vertical height of the two refracting surfaces. See, this is the refracting surface. Then this height is the, or this length is known as the aperture. This length is known as the aperture. Now we will learn about the sign convention that we are going to follow. Sign convention that we are going to follow while performing numericals or deriving the relations between the physical parameters. Sign convention. So for sign conventions, first you have to measure all the distances, from the pole. Measure all the distances from the pole. You know where is the pole? In the earlier slide I have shown you. Second, the distance measured from the pole in the direction opposite to the direction of incident ray are taken as negative. For example, if let me draw if this is the spherical surface, this is the principal axis, and if rays are coming, if rays are incident in this direction, if rays are incident in this direction, if rays are incident in this direction, so all the directions, all the measurement along this will be positive. Along this axis it will be positive, and all the directions taken in this direction will be negative. All the directions taken in this direction will be negative. Better, what you will always remember is that take the positive x-axis as positive and negative x-axis as negative distances. Just one condition, incident rays should always travel from left to right. The incident ray should always travel from left to right. So no need to remember how to take the positive, negative. Just remember one thing, or take all the rays from left to right, and therefore the positive x-axis will be taken as distances along positive x-axis will be taken as positive, and the distances along negative x-axis will be taken as negative distances. Understood? Third point, similarly, take the distances along the positive y-axis as positive. Positive y-axis will be taken as positive distances, and negative y-axis will be taken as negative distances. Understood? These are the three you should remember. So the refraction at concave surfaces. First, we are going to learn refraction at concave surfaces. First, we will take concave surfaces. Okay.
স্যার ইমেজিস ভার্চুয়াল হতে আপনি 8টা মিস করে গেছেন।
Okay. Virtual. Image is virtual. So refraction at concave surfaces when the object is real, object is in rarer medium and image is virtual, right? So we have taken a lens here, a refracting surface here. This is the refracting surface. This one is the refracting surface, right? And we have the pole of the refracting surface at this point. This is the pole of the refracting surface. This point is the pole. The center of curvature is at C, and we have placed an object O in the rarer medium. Mu1 is the refractive index of the rarer medium, mu2 is the refractive index of the denser medium, right? And we have placed an object O in the rarer medium. Now what happens? A ray of light OA goes and hits the refracting surface, and after refraction what happens? It bends towards the normal. See this line, the red line represents the normal on the surface. Let this be N. Let this point be Cn is the normal, right? And OA is the reflected ray, and after that it reflects to, let this be B. So AB is the refracted ray. Now angle OAC, angle OAC, the blue angle, it is equal to Y, angle of incidence. Angle, let this be image I is the image formed here. So IAC, this green one, it is the angle of refraction R, right? Because this angle is equal to this angle R, right? And the angle OCA is equal to theta. OCA is equal to theta. The object distance OP, object distance, object distance, object distance PO is equal to minus U. Why we have taken minus? Because we are measuring the distance in the opposite direction of the traveling of ray, right? In the negative x-axis. In the negative x-axis. So object distance is minus U. What is image distance? Image distance is equal to, image distance is EI, right? And that is equal to minus V, since the object is also image is also formed on the negative x-axis. And radius of curvature, and radius of curvature radius of curvature is equal to minus R. Radius of curvature is taken as minus R because it is also in the negative x-axis. Okay. Now from triangle AOC, from triangle AOC, from triangle AOC, what we can write? We can write sin I by CO. Let me write it, then I am explaining. Sin I by CO is equal to sin theta by AO. Now, why I can write this? This is according to Lami's theorem, using Lami's theorem. This is Lami's theorem. Now, if you don't know Lami's theorem, just revise it from any book of mathematics or physics. This we can write by Lami's theorem. In this triangle, let me highlight the triangle. This is the triangle AOAC triangle, right? Or AOC. This is the triangle. In this triangle, we can write this angle, right? Sin I. This angle, sine of this angle will be divided by the line opposite, side opposite to. It will be equal to this angle, sine of this angle, theta, and divided by the side opposite to OA, right? So this is according to Lami's theorem. Now, next. we can write this is equal to, we can write now sin I by sin theta, sin I by sin theta will be equal to CO divided by AO. CO divided by AO. Okay. Now again from triangle AIC, from triangle AIC, from triangle AIC, what do we can write? Similarly, we can write sin R by, so R is opposite to what? ICI. Side opposite to sin R is angle R is CI. So sin R by CI is equal to sin theta, sin theta by AI, sin theta by AI. So we can write sin R by sin theta is equal to CI by AI. Now if we apply Snell's law, what does Snell's law tells us? Snell's law tells us mu1 sin I1, mu1 sin I is equal to mu2 sin R. This is the basic formula of, generalized formula of Snell's, right? So this is equal to this. So what we can write? Mu1 sin R, sin I1, we can divide both by theta. So we can use this and divide both the sides by theta, dividing both sides by sin theta. So mu1 sin I by sin theta equals to mu2 sin R by sin theta. Now instead of sin I by sin theta, what we can write? Sin I by sin theta, we can write CO by AO, right? So we can write mu1 into CO divided by AO is equal to 2 sin R by sin theta is equal to CI by AI, right? Into CI divided by AI. Okay. Now, since this aperture is very small, since this aperture, what we use in our general academics, what we assume is that the aperture of the refracting surface is very small, right? So P and A points are very close to each other. So point P and point A are very close to each other. So we consider this point A and this point P, they are very close to each other. So we consider OA is equal to OP, means P and A are the same point, right? P and A are the same point. So we can write this as mu1 CO, mu1 into CO divided by, instead of AO we can write PO because A and P are same, is equal to mu2 CI divided by, instead of AI I can write PI. Understood? So this gives you what? Now from this we can write mu1 mu1 into, instead of CO what we can write? PO minus PC. You can write PO minus PC. For CO you can write PO minus PC divided by PO is equal to instead of Ci, right, instead of Ci, what you can write? Instead of Ci, you can write Pi minus Pc divided by Pi. Divided by. So, what is Po minus Pc from the diagram? Po minus Pc, or better, you can one step ahead. I can take you more. Mu1, mu1 into, you can write this as 1 minus Pc by P equal to into 1 minus C by P. So now, what is PC by Pi? What is PC? PC is nothing but capital R. PC is nothing but minus R, and PO is nothing but minus U. So your equation will become now U1 into 1 minus R by U. 1 minus R by U. Because PC and PO both are negative, right? This will be equal to mu2 1 minus R by I is I. So this is your equation. And if you just use this equation, you can get the final version is mu2 by V minus mu1 by U is equal to 2 minus mu1 2 minus mu1 divided by R. So this equation is very important. This equation is very important. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R, right? This equation is very important, and it is known as Gauss equation for refraction at a concave spherical surface, right? At a concave spherical surface. Similarly, what you can do is you can find out the other relations if the object is virtual. If the object is virtual and the image formed is real, object is virtual and the image formed is real, then what happens? Then this equation just modifies into, it remains same. When the object is real and lies in the denser medium and the image is virtual, then also it remains same, just with a minus sign. Just with a minus sign, it becomes just with a minus sign, means mu2 by V, instead of, it will become mu2 by U minus mu2 by mu1 by V is equal to mu minus 1. So there are two more expressions you can remember. I just let me write those two equations, then it will be easy. So when the object is virtual, object is virtual, object is virtual, then the is virtual and image is real, then the expression becomes mu2 by V minus 1 sorry 1 by U is equal to minus 1 by R. same. And if object is real, object is real and lies in denser medium, lies in denser medium, and image is virtual, image is virtual, then expression becomes mu2 by mu minus mu1 by v is equal to minus mu1 by v. So these are the three expressions that you need, two expressions that you need to remember, right? So we can do problems from this.